we can start writing a quantum machine learning code without doing anything. Is it clear? Now my question is that, do you want to see the program or understand the mathematical part? Then I will stay in the code. If you want program, I will share the code, and then you have all WhatsApp connection.
Yes.
So that I will do, then you can do that. I will share 3 programs, you can do. That is much easier than doing here. So that's fine. Not the point, right? So program I will share with WhatsApp. But the mathematical concept is where you can ask me more questions. Is that okay? Mathematics okay? Everyone? I need someone there to clean it. How quantum computers are solving or operating in a unitary operation model? Anyone knows? We know very well quantum computers are operating in the unitary operation, right? They are performing unitary operations. Yeah, yes. So if someone can take photo before that, then
Yes.
yeah, take a photo, share it. Of course, it is recorded, not necessary, but still have a static photo. Anyone knows how quantum computers are unitary? How quantum computers are performing unitary operations? Because that is essential to understand the mathematics. Before I am jumping into the mathematics, I want you to be very clear how quantum computers are performing unitary operations. Anyone the last one? Unitary. How quantum computers are performing unitary operations? Through matrices. And those matrices are created with the matrix composition, such that whatever matrices we are having, they are composed into one single matrix. Then we are performing the operation only on the qubit with the matrix. Okay. Now assume that, let us take the same circuit what we have, this 2 qubit, right? If it is 2 qubit, your vector will be 1, 0, 0, 0, right? This is the state vector for a 2 qubit. How we achieved this one? By using product. This is Kronecker product. Now, this is performed, or we are performing a matrix times vector using, see, for example, let us keep this alpha 1 1, alpha 1 2, alpha 1 3, alpha 1 4, then alpha 2 1, alpha 2 2, like that, alpha 4 1 and alpha 4 4. I purposefully removed the 0 in subscript to make it much easier. But in literature, they will start with the 0 in subscript, right? So you have a 4 by 4 matrix, which is operating on a 4-element vector. All are complex matrix, complex vector. This is clear? This is the basic infrastructure. How we get this matrix? That is where the important concept comes into picture. Remember, we had Hadamard tape and Hadamard tape. And what is the matrix for Hadamard tape? 1 over root 2, 1, 1, 1 minus 1. 1 over root 2, 1, 1, 1 minus 1. And if you multiply these two things, what you will get? 2 by 2 matrix. But we need 4 by 4 matrix. Again, what we have to do? Kronecker product. Why Kronecker product? The Kronecker product will give you a 4 by 4 matrix. Now you got the idea, right? All operations, whatever you are doing in quantum circuit, they should be enlarged or they should be rewritten by using Kronecker product such that they are compatible with your input state vector. That is the key here. Your input state vector will have 2 power n element. If you have n qubit, your input state vector will have 2 power n element. So to transform the 2 power n element state vector, you need 2 power n by 2 power n matrix. How to achieve the 2 power n by 2 power n matrix? by performing the Kronecker product of individual qubit gates. Is it clear? It is the key point. If you understand this one, everything will become much easier. Now, if you have sufficient time and patience, you can build the matrix for the quantum circuit what I have given. Only thing you should know, theta 0, theta 1, then omega 0 to omega 3. If you know these values, you can build those gates, matrix for those gates. Am I right? I am not expecting to do now. I want to hear the confirmation. Yes, given theta 1, theta 2, or what are the input parameters and then weight parameters, we know how these matrices are formed. If you know that, we can comfortably move to the next step. If you don't know. If you recall the circuit what I drawn first, Harman gate followed by Ry of theta 0, Ry of theta 1. If you recall the matrix for Ry theta, now you can explore. What is matrix for Ry gate? Can you check? Can someone tell me the matrix for Ry gate? 0, I, minus I, 0. That is what Y gate. This is Y gate. But I am here having Ry gate. Can someone check the matrix for Ry? Because I don't remember that. First I can check here. I remember P gate.
So I think it's theta cos theta minus cos
This is for Y gate. For Ry gate?
Yes, sir. Actually, 1 second, sir. I'll double check that, and I don't want to.
Please check it because I don't remember. That's why I asked you to check it. You can check it. All of you do that one because have you found Ry gate?
Yes, sir. It's cos theta by 2.
0, right? Here 0, right?
So it's R by for any theta, right?
Oh.
So cos theta by 2.
So which element you are telling cos theta?
Yes, sir. First element. So
This
the
one?
multiplication theta. So that is the one here. The I instead of that it is sin theta by 2.
Sin theta over 2.
That is minus sin theta by 2.
Right?
Sorry, I
Minus I.
yes sir, yes sir. Minus I, minus.
Here positive I.
Yes, I think it's possible. Right?
Yeah.
It's wrong here. Really sorry.
This is correct, no problem. Now I recall. This is your matrix for Ry gate. Theta, let us assume that pi over 2. Now you know the matrix. Assume that for this your theta is pi over 4. Now you can form the matrix. Then perform a Kronecker product. That will transform into a 4 by 4 complex matrix, which can transform your 4-element state vector. Is it clear? You may not expected that I am going to use black hole. But that will give you the good, what is called engaging your thought process rather than display. After you have done this one, I will share the code. You can start working on that. This portion must be very clear. Next, as earlier I pointed out, once your circuit is ready, that circuit is passing through feedback mechanism, then loss function, optimizer, then you will repeat that circuit, that number of epochs, whatever you want, then it will run it. Now my question is that, can you use this infrastructure for iris classification? That is a question. Of course, mathematically we saw and we explained. Looks like okay. That is looks like easy to understand. My question is that if I am planning to for iris classification, how many theta I will need? For iris classification, if I am going to do the circuit, I will need theta 0 to theta 3. So theta 0 will be used for sepal length, theta 1 will be used for sepal width, theta 2 will be petal length, theta 3 will be petal width. That is how we are mapping. You remember iris data set, all of you remember the data set. Sepal length, sepal width, petal length, petal width. So we need 4 qubits, and first qubit will use theta 0, second qubit will use theta 1, which is sepal length, sepal width. Third and fourth will use petal length, petal width. Now it is much easier. Now you may start thinking, if that is the case, I can write a quantum neural network of many of the problems. Earlier you may not have that clarity. How I can use a quantum neural network for my real life problem. But this connection will help you to understand this is how the iris classification is built using quantum neural network. Here I will take a pause. If you have any question, I will answer before jumping into the next concept. All good, right? Right. I will share the program with you now. Okay. Sometime in the meantime, you can ask question. If you have any question. That's all. Any question? Before you are jumping into the coding, you can ask me any question. It may be general career related question also, not necessarily technical question. Mostly when people start with the mathematical concept, they are afraid about asking questions. Anyone planning quantum computing as a career? How many of you are planning quantum computing as a career? Very good. 3, 4, 5. Yeah, I counted you. 5. See, on a Saturday, I really appreciate your what is called, how to say, the interest in the subject, because on a Saturday morning, even though you are not very clear about whether quantum career or not, you are attending and listening to a mathematical concept which is wrote on the blackboard. You need a lot of guts to attend this kind of session, I tell you. And the reason is that if we know this is my career, we can put forth our efforts day and night. But quantum still is not perceived as a very good career by students. The reason is that if you look for Naukri or any job portal, Glassdoor or what is called, earlier it was Monster, now it is called Founding. If you search job portal, you can't find many jobs in quantum. That is one reason why student community is not very much interested in quantum computing career. Very few people knows that there is something quantum is going to come in future that will have a great career growth. Let us start focusing on that one. It's a very limited number. Within that those limited number, when they come to know that it involves lot of physics and mathematics, they will drop. You understood? Because we are software engineers. We are very good at Python programming or C programming. Now, if I want to pursue quantum computing, I need to learn mathematics and physics. It is like deviating from my core competence. Correct? My strength is programming, then why I have to learn mathematics and physics to become a quantum computing professional? That is also shying away many of the students to pursue quantum computing as a career. These are all real facts. I cannot tell you skip mathematics, you focus on programming, you can become quantum machine learning. That is a lie. That is not possible. Without mathematics and physics, remember Sir also talked a lot of physics, right? Yeah, physics is important. Without mathematics, physics, you cannot pursue quantum career, whether it is quantum machine learning or quantum optimization or any quantum hardware. But is it really worth to spend that much of time? What is the promise that I will get the quantum computing jobs? I am a person who is following this industry for 20 years. With that, I am telling you. With that experience, I am telling you, this is the right time to start pursuing quantum computing as a career. Now, companies started hiring quantum professionals. Predominantly, they are hiring based on your social media market posts. It is surprising, but that is how companies HR team initial level screening is predominantly done with your, of course, your qualification, in which college you are studying. Those things are very important. Next screening is your social media presence. How much you are shouting about quantum computing. More shout, more chances for consent. So now these things will cause some confusion. Oh, we have to do all these kind of social media marketing, then only we will get it. Initially it is like that. But later, one point of time, I'm just sending. Yeah, I have sent 4 months. It's not yet, still it is true. So what I'm thinking, you need a strategy. Yeah.
Well, the field of, I wanted to ask, the field of photonic feels very promising and for easy so that means a lot more real than the quantum part. So what do you think about that?
EC, which part from EC? You are from EC.
Yeah, quantum, basically, photonic quantum.
Photonic quantum computing. So photonic quantum computing is gaining momentum because it promises room temperature quantum computing. That is the main reason. Any other technology, they need at least 20,000 Kelvin temperature. And superconductor is expecting absolute zero temperature. Photonic computing is the one system which promises that you can operate the 3 lakhs Kelvin. That is main reason why photonic quantum computing got lot of attention, and then there is a good amount of research is going on. IISc Bangalore is also working on photonic quantum computing. Professor Anand Selvaraj is working on that one.
As we are coming to the limitations of the symptoms and atoms, people like that is the next.
Yeah, obviously photonics is promising. The one challenge with the photonic is that implementation of native gates. In superconducting or ion trap or neutral atom, except the photon, implementation of native gate is somewhat much easier compared to photon. In photon, if you see only, it has 2 native gates, and using these 2 native gates, you have to implement all other gates. That is one reason why photonic quantum compute circuits are higher depth or more deeper compared to other circuits. If other circuits, if you write a 1000 layer, here will need 2000 or 2500.
Right, because it's due to the noise stacking of acid.
Yes, that is, then the more depth increases, noise will accumulate. That is one reason why photonic systems are still not getting the momentum what other systems are getting. But they are promising as a quantum communication and a subsidiary computing capability. You need not to keep photonic quantum computers as your main computing capability. You can keep that as a subsidiary, like processor, GPU, Like that, quantum also you can have superconducting as a master computing capability. Under that control, you can have photonic or neutral atom balancing. Moving forward, it is not supercomputing alone. It will be complementing each other. One quantum infrastructure will have certain number of qubits with superconducting, certain number of qubit with the neutral atom, some other with the ion, trapped ion, something else with the neutral atom, something else with quantum annealer. This will become your quantum computing infrastructure. So personally, I feel that you should keep open for adopting all quantum technology. You should not attach it to one specific technology. If you are a hardware person, obviously you have to choose only one because you cannot master all frameworks. So the platforms needs the deepest knowledge in the hardware. So if you are a hardware person, choose one technology, then go deeper into it. If you are a software person, try to understand what are the native gates in all other technology. Try to build one quantum computing capability which is capable of leveraging the capacities of other technologies, then build a one solution. Can you share this? Okay, now all programs you have shared, right? Now all you have received four programs. Yeah, please.
Everyone check the group. I sent all the Python notebooks sent by Sir. We'll put it on the GitHub later, but please open WhatsApp right now. Download it from there, and you can follow along the lecture with that.
Yeah, what is your question?
Sir, is the right to see the functioning photonics is more of implementation function more than a physical function?
It is both the physical constraint, implementation constraint, both. When it comes to photonic quantum computing, I can't say I am an expert in that one because I am a software person, not a hardware person. That is first thing, a disclaimer. But I know a little bit about your question. The infrastructure not only matured, that is true after the arrival of NV center. Prior to that one, photonic was not popular. After the scientists are able to trap a photon, it's inside NV center, they are able to build a lattices of that one. Then they are confident that we can build a photonic quantum computer. And that technology is somewhat maturing now. The moment it is matures, we can find more promising solutions using this photonic technology. Now we have reached the 800 millisecond coherence time using, that is the longest coherent time what we have achieved in quantum technology since 1925. So that is one reason why photonic systems is promising a better computing, quantum computing devices. But unfortunately, still it is evolving. Yeah. So that answers your question. But I cannot go more deeper in technical into that one. That is my limitation. Any other question from anyone? Yeah, please.
Sir, the thing is, there is a company called as Q5AI.
Yeah.
So it has proposed that it has built a quantum computing chip called as Kaveri.
Correct.
Which is to go, right? Can you tell something about that? What it specifically is?
Okay. I will make it as a generic rather than reference to Q5AI because I don't have any rights or it is not ethical to talk about some other company. I will talk about the technology. Right. So there is a new approach being adopted by many quantum hardware organizations called open source superconducting qubit platform. See, this open source qubit platform allows anyone who has the fund to invest, they can assemble those cryogenic systems and data infrastructure system, shielding, then various layers, all those things into one single quantum computer which is based on superconducting technology. Whatever you are asking that is related to that approach, they are building 25 qubit system. There is one more company called Qubit Force. I'm not sure most of you may not hear that company. This is first time you are hearing. They are operating from Amravati. They are also working on similar technology and their quantum computers are deployed into Amravati. You may not know the news now, but April 14th you will hear. They assembled or they installed. I'm not sure about the number of qubits, but that is follows this approach. So now, if any of you are decided to build a quantum computer, you need not to worry about spending lot of money because of the proprietary systems. But there is an open system available now. It is something like IBM announced PC during 80s. During 80s, computers are proprietary systems. No one can assemble it. But in 1980s, IBM announced their assembling structure as an open architecture. After that, many small companies started assembling computers, desktops. Something like that happening in quantum also. Now there is an open system, open hardware system, which is supporting us qubit systems. So that will be helpful for you. Any other questions? Being in industry, I know a lot of market niche. You can ask me. If no more question, you can start practicing the program. I have shared the 4 programs, right? One is QNN, other one is estimator QNN, other is the classifier. And there is one more program which is using the QNN to solve iris problem. You do that one. If you have any question, ask me. In the meantime, I will think about if there are any points you need to know. I have another 30 minutes. If you want, you can make it as a Q&A. I always thinking about the optimization. You always come to Q&A only. I'm not getting Q&A. Quantum optimization comes into my mind. But we can have a Q&A for the next 30 minutes. Or else you can do the program. While doing the program, if you have a question, you can ask me. Whatever you prefer, you can do. While others are doing, yeah, please.
Centers, right? So I have a few quite specific doubts about this.
Please.
I'm right now working on an ME center project, and one of the issues that's happening is this spin configuration. Basically, an ME center, it has the seven excitations. You have E -1, 0 and +1, G -1, 0 and +1, and the series which is spin 0. And the issue that happens is, if an electron or a particle is in the excitation state of -1, it can only go back down to the ground state of -1, meaning the spin has to stay. So, do you know any possibility that I can change the spin as it moves down from the excitation level to the ground?
No, because your question is beyond my knowledge level. But I can connect you with the right person who can answer the question. Yeah, sure. Ping me, get the connection. I will get their permission before.
Yeah.
Then I will connect with him. He is an excellent person who can answer the question.
Okay. His name, if I look up his research, maybe he might have.
He is from IIST Toronto. IIST.
IIST.
Toronto. I will give the correct contact. Only thing I should get their permission before sharing with you. They will answer your question. Exactly the same thing what you are asking, something similar to that one they were discussing when I was there delivering session on like this. They asked me that time also I don't know. That I told because it is not possible to everyone have all the knowledge. Then I told no, I don't know. But he introduced me to his professor who knows that very well. Hope that program makes sense, right? Those who are serious about quantum programming, I have a request. You start exploring Julia. There is a language called Julia. The new generation quantum packages are coming as a Julia package, not as a Python package. So blockade, QRA blockade, that is one example, which is as a Julia package. So I recommend explore Julia also. In Julia, there is a package called yaw.jl. Yaw.jl. This is a Julia package. Explore that one. That has a good performance. The reason why I am referring Julia, the post-quantum cryptography modules which are written in Julia, they are outperforming Python or any other package. Ideally, you should go to Rust if you are planning PQC, but most of you, I'm not sure whether you are planning to go to Rust. At least you can go to Julia language. Julia will give you a better performance compared to Python-based packages. Unfortunately, many quantum companies are releasing Python package only. For that one, you have to go with Python only. But wherever you have the Julia package, you can explore Julia package. That will give you much better performance compared to Python. Okay, look, you started working on the program, right? If no more questions, I can talk about the quantum inspired approach. Is that okay? Can we jump into quantum inspired? How many of you heard about the quantum inspired earlier? No one. Then it is the right topic to start discussion because current market is hiring quantum inspired people compared to quantum people. No, it is, you are referring to PQNN, right? PINN, physics informed neural network. Yeah, physics informed neural network, we can compare, see, that is the word inspired, always nature inspired optimization, quantum inspired optimization, the word inspired tells that the algorithm and the approach is derived from that particular technology, but they are deployed on a different platform. That is the word inspired. Inspired means concepts are coming from one technology, but implemented on a different technology, which is a radical change rather than empirical change. Now, we know there are three quantum behaviors, right? Superposition, entanglement, and interference. And we all know that quantum computers are natively parallel. And which of these properties offering the natively parallel processing capability? Indeed, all. Combination of all will give you natively parallel processing capability to quantum computers. Second question, which of these behaviors can be implemented in a classical system? See, these are all quantum behavior. obviously they can be implemented only in quantum system. That is very clear, right? My question is that which of these properties can be implemented in a classical system or digital electronics? We can implement this and this. If we put it classical. But this cannot be implemented. We cannot build an interference system using a classical system. We can simulate. That is the difference. We can simulate, but we cannot implement. There is a difference, implementation and simulation. Simulation, it is clearly tells that it will operate with a limited capability just to simulate the system for experiment. But the superposition can be implemented in a classical system for performing some operation. Now, let me write this Python code, a simple Python code. Import CMath. Import CMath means complex mathematics. We can import math, which will perform real number calculation. But if you import CMath, you can perform complex numbers. V underscore 0 equal to complex 0 comma 0j. But instead of 0 comma 0j, I am writing 1 comma 0j, which is equivalent to 1 plus 0 I. Are you able to understand this one? So what I am doing, without a quantum computer, I am creating a 0k. That is what I am doing now. I am creating a 0k in a classical system. Now I can create V1, which is complex 0 comma. Okay. This is other way around. 1 plus 0i, comma 0 plus 0i. And 0 plus 0j, these are j, sorry, comma 1 plus 0j. This is the correct number. It should be a vector of this one complex number, and this is another complex number. And step by step I am increasing the complexity. Instead of explaining one go, I am explaining it step by step. So the correct representation of V0 will be equal to the list of complex 0 plus 1 plus 0j, comma complex 0 plus 0j. This is the correct 0k. Am I making sense now? And similarly, if I want to create psi k, V underscore psi, I can create complex 0.707 plus 0j, comma complex 0.707 plus 0j. This is the psi k. I created a superposition in classical system. Now I can import a library called linear algebra algorithm. Then I can implement all kind of matrix and then vector operation on top of this V underscore psi. So what is the meaning? You can create quantum operations without using Qiskit or without using any quantum libraries, which means a mere classical algorithms or classical packages can be used to create quantum operations. Is it clear? But one thing I cannot do, interference. Except interference, I can build the superposition, entanglement, any gate operations, all those things I can implement. Now you may have a question. How can I implement a Hadamard gate, right? What is a Hadamard gate? Hadamard gate is again a complex matrix. Here I created a vector, right? Usually what I will do when I implementing a solution, I will convert this into NP array of this one. Then it will become a proper array. Then I will use NP array to create a complex matrix which will have 1 over root 2 plus 0 j, 1 over root 2 plus 0 j, 1 over root 2 plus 0 j, minus 1 over root 2 plus 0 j. That is a Hadamard gate. Then if I multiply that Hadamard gate with P side, I will get superposition by superposition or 0 gate times, Hadamard gate times 0 gate. I am performing the superposition of a 0 gate. Then I can call out those operations multiple times. I can simulate the quantum circuit using these two libraries. Is this clear? This setup is clear, right? Now implement this solution on a HPC or a supercomputer rather than your desktop. Now what are you doing? You are leveraging a mature infrastructure for a new type of algorithm. I want to introduce a new word, complex valued neural network. Now think about these quantum capabilities which are built on a classical system can be used to implement complex valued neural network, which is a classical algorithm but operating based on quantum principles. This approach is called quantum inspired machine learning. Now you can extend neural network or graph neural network, or you mentioned PINN, right? Physics informed neural. Someone mentioned the physics informed neural network. You can enhance the quantum physics informed neural network and quantum. Yeah, these are all possible with the help of this infrastructure. Now you will start understanding it is our imagination. If you are very good at the concepts, wherever you want to deploy, you can choose. If you know the approach and underlying libraries. Now, I want to think about this way. Whatever I'm doing here in Python, you think about doing this using Rust language. There is a language called Rust. All of you know, right? Simply think about this one. If I am able to do this in a Rust language, what will be the performance advantage of that program? That is what industry is looking for. Now industry is working on that kind of infrastructure. When I say quantum inspired neural network or quantum inspired machine learning, I am not referring Python programming. I am referring Rust programming or Julia programming, which is based on this kind of approaches. I used Python here because it will easily you will connect the dots. But in industry, we are not based on Python. We are moving to Rust. This information will be helpful for you to publish a paper. Imagine that you are building some complex valued neural network to solve a problem and publish a paper, then that will gain good attention in the industry. Industry may be interested to hire you as an intern because that is what we are looking for. Any other questions? Anyone have any other question? Otherwise, I will hand over to your organization. But I am happy to answer because we have another 15 minutes. If you have any question related to career or anything, you can ask me, I can answer. I'm giving you over to.
Yeah, I think, again, thanks a lot, sir. I think I have to announce this. Things didn't go exactly as planned, and sir really put in a huge favor for us. We contacted him very late at night, and I'm not sure if that was very professional of us. I'm sorry, but thanks a lot, sir. Thanks a lot for coming here.
Good.
And we genuinely really enjoyed it. I will answer. Just 1 second. Yeah, we want to.
In the meantime, I will engage. If anyone have any questions.
If any of you have any questions, please feel free to ask sir. And yeah, we can be ready to answer.
Yeah.
So what do you think is the progression of the industry in the next like 20, 30 years? Like how do you think this is gonna go? What do you think? Like as a general, because if you look at AI, like no one expected it to blow up this fast. So do you think quantum will have like a similar kind of effect on like all industries, or will it be like slower, or like what do you think? Like, that?
I will tell you. I have to go back to history. My first AI program I written in 1992 using a language called Prolog. After successful implementation of natural language processing, composer, meaning that a parser, grammar parser, that was my first project. That time I worked on a 752 kilobytes memory system. My desktop had only, that is the highest memory what I can afford. Hard disk capacity is 16 megabyte, 16 MB. That is what the hard disk capacity. 732 is my RAM memory. That is where I write my first AA program. Obviously, we know very well with this hardware we cannot proceed with the AI. I myself stopped working on AI because I know very well there is no hardware. But at the time, I predicted after 20 years or 30 years, AI will become a big success. That's what happened. Now, quantum is in that such a stage. 1100 qubit is nothing. We cannot do anything. But in the downstream or in the upcoming days, in another 10 years or 20 years, the number of qubits, the quality of qubit, and the variety of qubits will grow such that artificial general intelligence, artificial super intelligence, and personalized medicine, and weather forecasting, and many of the industrial optimization problem, computational chemistry, material science, all these branches will have a more powerful solutions based out of quantum technology. It's not only quantum computing, it's quantum sensing, quantum communications, quantum algorithms. Combination of these three things are going to contribute to these things, and this will result in an improvised space research and healthcare and optimized business processes. All those things become a realistic timeline. See, imagine this way: you have 1 trillion euro pension fund. What I'm telling is the fact. The pension fund volume of euro is in trillion euro. And imagine that you are having a quantum finance algorithm which will, sir told, right? The BBA department students are writing a quantum finance code to find out the minor variation. We call it the Greeks. If a quantum algorithm is able to understand the Greeks, the changes in the Greeks within a short span of time, because feature and option should be completed within 9 a.m. to 3 p.m. Within the period, we have to optimize it. Now think about optimizing a 1 trillion euro with 1% using a quantum machine learning algorithm or quantum finance algorithm. It's huge. And I'm working with the JNCA people in Bangalore. They are material science people. I'm working with them. If their research or whatever we are contributing, if it is going big, we will have a new material. So the industry is going to gain a lot because of quantum technology. In another 20 years, quantum technology will be everywhere. And it won't replace classical. Hope that answers your question. Any other questions? Yeah, I think I'm done with the questions also. The overview. Yeah, please. Any other question also we can engage when Karthik is coming. Yeah, my number is 81. If anyone want to note, reach out to me, note my number. 8123096141. And my company name is Quantum G. This is my organization name. I am founder and CEO of this organization. I would say former founder and CEO.